Hi guys, and welcome back to the channel. In this week's video, I'm going to talk to you about DBT, what it is, what problems it solves, and if you should consider it for your own environment as well. So where did it all begin? Well, back in 2016, DBT was founded by a company called Fishtown Analytics. They originally created the product as open source, and it made money by selling consultancy into their customers to help implement it. Now, originally that product, as I mentioned, was set up as an open source. Today, they have 9,000 companies using DBT. The enterprise product, and I'll flash a screen up shortly, which details the 3 different options available to you today and their prices, which is publicly available on DBT's website as well. But their enterprise edition, DBT Labs, has 1,800 customers and it's grown very rapidly indeed. 6 times the annual recurring revenue they did in 2021 alone. So what makes it so popular? Well, just last month, I'm recording this video in March 2022, in February, they were able to secure Series D investing of 222 million. Now, notably, Databricks and Snowflake were part of the investment team that helped fund that round of Series D investment. That values the company on those figures at 4.2 billion. So it's very popular, it's grown all of the time. Obviously, those companies see a lot of potential in it at the moment. Over the last 2 years, it's almost become the de facto standard or the industry standard for data transformation. So on the next couple of slides, I'll explain exactly where it fits in and what problem it solves. So before we can understand where DBT fits in, we need to just do a brief history lesson over ETL versus ELT. Now, if you don't know, ETL stands for extract, transform, and load. And this came before the advent of cloud computing and highly scalable, elastic compute available in the cloud today. So this is when you had your on-premise technology in your data centers within your own organization. In that case, you had your data sources. They were typically your customer-facing systems, your transactional systems, sometimes referred to as OLTP by the technical guys. Now, you had data feeds coming in to your data warehouse platform. Now, during this extract mechanism, you then also had to use the processing power of your specialist ETL tool, such as Informatica or SQL Server Integration Services, for example, to also carry out transformations along the way. So often you need to carry out a transformation, land it into your data warehouse, pick that data up again and apply another set of transformations before landing it back to your warehouse again. That process was very time consuming and very costly because you're constantly writing data to and from disk. But at that time, that was the approach that you had. There was limited options. Everybody did the same thing. So ETL was all about extract, transform the data, then load it into your data warehouse and make it available to your BI tools, your dashboards, or any AI ML tools, or operational reports, or downstream data consumers. Now, with the arrival of cloud data platforms such as Snowflake and Google BigQuery and Amazon Redshift, for example, storage is cheap, highly scalable, and compute and resources are available on demand. And so that shifted the paradigm quite a lot, where ETL was then replaced and reordered with extract, load, and transform. People quite quickly realized it was much faster to initially extract and load your data sources in raw format as quickly as possible onto your cloud data warehouse. Once it was in here, you could then transform the data in place, pushing the logic to where the data lives, and really using and leveraging the processing power and massive scalability of your cloud data platform. From this, and to make this job easier, there were certain data loaders such as Stitch or Fivetran developed, and these were plug and play data loading devices which filled that gap where if you had off-the-shelf packages in your data sources, like many people, for example, would have something like Salesforce and various other ERP systems, they all looked the same and shared the same schema. It was then very easy for companies like Stitch and Fivetran to come along, offer a plug and play mechanism to say, we'll extract all the data from your data sources because we know what they look like, and we'll push them straight into your data warehouse. So then you can focus your time with your custom business logic, transforming that data and getting it ready for your BI and AI ML tools and any other data consumers downstream who needed to use that data. Now, this is where DBT comes in. So typically within your data warehouse, you'll have a number of layers where you take the data from its raw format, standardize it, apply business logic, and get it into that format that's optimum for use for reporting and analytics. So here I've just got a very simple example. We've got a raw layer here and a transform layer here. The data comes in and arrives in its raw format, which looks very much like it does in its source system. This is the space dbt plays in here, essentially. And what dbt does is it lets you as the user just use SQL predominantly. That's not the only case, but we'll get to that in later videos. It's not really the subject of this one at the moment, but predominantly you can use SQL. You can write your transformations here. You don't need to worry about all of the different tools and technologies and integration points that you used to have to do in the old world of ETL. That allows you then to spread that work and democratize your data, which is a term that's used more commonly these days. And that's when you can have what dbt refer to as analytics engineers, which then can also start writing their transformations and business logic in dbt in a standardized and repeatable way. And dbt will also know how to orchestrate those workflows. So which steps need to run before what, it will automatically understand that and be able to orchestrate those data flows as you move your data in its raw format into a transformed and optimized format ready for downstream consumption. So this is the space dbt plays in it. It doesn't do the E, it doesn't do the L, but it does the transform piece, and that's the job that it carries out. So you're still going to need a tool to onboard your data onto your data warehouse and load it, but to do any transformations it's dbt. Now going into a little bit more detail about dbt, how dbt works. So it's got three main components essentially. So we talked about the development one just before. That's where you write your transformations and apply your business logic to move your data from its raw format, standardize it and curate it into your format for downstream activities. It also integrates with Git for version control, allowing you to roll back any changes if necessary, but it's also very good practice that everybody follows this standard, because then you can operate in a CI/CD space, which is continuous integration, continuous development, which allows you then to deploy your code from version control to a test environment on a regular basis and get early feedback and validation on your code. And as part of that process, you need to be able to run tests to check if the data that you're transforming comes out in the format that you expect, as well as producing documentation as well. So the three areas dbt plays in, and it really plays to the modern data teams in data ops world, where you've got small modular incremental developments written across the business, not just in the IT space with data engineers, but also out in those subject matter expertise areas scattered across the business. Everybody follows the same standard and pattern and version control. Everybody also has to ensure their code is tested as well. And dbt comes with these three features to ensure that the code quality and the build is standardized and repeatable throughout the entire process. So that's a very quick overview of what dbt is, where it fits into your data ecosystem, what problem it solves, and why it's grown exponentially. I'm going to dive into a real world use case now for JetBlue and talk you through some of the elements of that from a business perspective and how dbt and Snowflake was able to accelerate JetBlue's data journey. Hi guys, I just want to take a brief pause from the video at the moment just to let you know that my latest book is out now, ready to order from Amazon. It's called Mastering Snowflake Solutions. And this is all about how you design Snowflake and package up its out-of-the-box capabilities to solve common real-world challenges. 100% of the royalties I receive all go to charity. Okay, let's get on with the video. So this is one of the key success stories of dbt and Snowflake, and it's JetBlue in the United States, who are in the airline industry. And there's a couple of things on this case study that I'm going to point out to you that I found interesting. I'm going to post the link of this in the video description below. And the first key point I want to call out on this case study is this bit. And it says in 3 months, the data engineering team migrated 26 data sources with 1,200 models to dbt. And in that process, they were able to add 6,300 data quality tests. So imagine how long that would take if you actually had to hand code that amount of data data quality tests manually. In DBT, you can just switch them on automatically as part of your build procedures. And they also implement a SQL style guide that essentially is part of DBT's best practices. Again, I'll post a link beneath the video. But if you're interested, they make available their own style guide, and essentially what that is naming conventions and configuration for the model process and the coding standards they use throughout their project. The whole point here is that implementing a style guide standardizes code practice across the organization of all DBT users and makes everything more consistent. You can see here that they took advantage of common table expressions or CTEs, so taking advantage of more efficient SQL procedures which are available in DBT, and it's the typical way that DBT generates the SQL code behind the scenes. And as a byproduct then, you can see that it's freed up their data engineering team to do more things. So that basically means add more value, and they're able now to double the number of data sources available within Snowflake and DBT because of the economy of scale and the efficiency and automation that DBT provides. The next key point is here, and this is all about the business process. So one of their data engineers is quoted as saying that every C-level executive wants more questions answered with data. They want it faster and they want it in many different ways. I'm sure this sounds familiar to all you guys out there. Given these C-level executives, the data that they need doesn't come with an increase in cost of new infrastructure. It's literally Snowflake's pay-as-you-go consumption-based model. So you pay based upon how many credits you spend, and credits are directly related to the amount of compute, so the amount of activity that you're working on the data with. If you don't touch the data, then you don't actually pay any more money. Mention here that they couldn't work on their legacy system, which used Microsoft SQL Server Integration Services pipelines. By doing that, they just needed to rebuild everything from the ground up. So what they decided to do is when they went with DBT and Snowflake and rebuilt the data infrastructure and data workflows, they eliminated that data engineering bottleneck. So if everybody from around the business is asking for data, they're all going to the data engineering team. That data engineering team then needs to onboard the data sources, transform the data before they can make it available and fulfill the requirement. That then acts as a bottleneck because you're only going to have a proportion of data engineers compared to everybody in your business who are data consumers and asking questions of the data. So by changing their approach, adapting to the needs of the business, Snowflake was brought in with DBT over the top, and that allowed analytical developers to help create those pipelines in a consistent and repeatable way that DBT supports. And this is a really great example here where, again, the guy who works for JetBlue that they interviewed says data engineers spend all of their time in the data, but they aren't necessarily the experts of how it's used by the different business functions to generate insight. So what he's saying there is you've got data engineers who are highly skilled technical people who are understanding how to orchestrate and build data pipelines, but they're one step removed from the business. So they don't necessarily know exactly what the business needs. So often you'll have the business ask a data engineer for something, the data engineer will make some assumptions and deliver that data back. But this is a great example here when the business question comes up around the number of passengers on a plane. Everybody would think that's simple initially, but when you drill down, he mentions, do you mean the number of paying customers or the number of seats occupied, which includes crew members or not? Do you include infants in the lap? What about pets? So there's lots of different ways you could answer that question depending on the assumptions that you make. And that's why putting the data into the business user's hands to be able to make their judgments in the best way possible. It obviously requires a certain level of maturity and data literacy around the organization of how best to use data in a consistent way. But that's the point that they were striving to get to, and that's where they were able to get real value. Finally, I really like this little table in the case study as well, where it compares the traditional central ownership over data, where a central data team is responsible for all data provisioning and data transformation. Data quality testing is minimal, happening only after the data set is deployed. Data transparency to the business is low. The warehouse maintenance is ongoing and expensive. To move to the shared collaboration on data, so this data democratization model, where the central team provides the tools and framework to empower analysts to get involved and participate in that development process, but within certain guardrails and standards. And that means anybody who knows SQL, especially with DBT, can start to contribute and add value to that entire process. Compliance is also catered for because DBT can produce really good documentation out of the box with a click of a button. Integrates well with version control, and you must use it in a certain way. And data testing is embedded into the tool. And because you've got version control and testing and documentation, that really helps with the transparency of data and data movement, providing data lineage and full transparency over versions of the code as it's changed over time and who changed what from the version control. So that's it. That's a short video, part one of a series on DBT. That's all about what it is, what business challenges it tries to overcome, where it sits within your data architecture at a high level. In the next videos, I'll be getting into more detail in terms of how then you set that up for the first time on top of Snowflake and integrate it with version control before we move into more processes around creating models and getting our hands dirty with the code. I hope you found that useful. If you did, don't forget to like and subscribe. New videos coming soon.